Good morning, ladies and gentlemen, on the last day of April, April 30th, 2020. Man, what a month, what a month. Alright, today we are going to finish talking about, hello Minerva over there, we are going to finish talking about radicals today and roots, but specifically we're going to be talking about ranges and domains to start off with, because I want us to do some graphing. In order to do graphing, you need to understand some domains, and you need to understand some ranges. So a domain is the set of all possible input values, commonly referred to as the x variable, because we assume the x to be the independent variable, which are going to produce a valid, Minerva girl, a valid output from a particular function. Now, what it means by valid is that if I put in an x value in, I'm going to get some response. Now that might not make sense, but it's very important when it comes to radicals and roots, because there are some values that you cannot put into a radical and get an actual number out at the end of your calculation. But once again, domains deal with the x values, and by consequence, the range deals with the y, and I believe there should have been a set parentheses over there, but it doesn't matter. The range is a set of all possible output values, all your possible y's. Where is your graph actually going to appear? Is it going to appear on the top? Is it going to appear on the bottom? But that's what it means. Now, we need to see, why is the domain and the range limited for this radical equation? Well, first, if you want to, and I will break these up amongst colors, and I'll do red for the range. Red for the range. Well, first and foremost, the thing we need to know about radicals is every radical starts typically at 0. It doesn't start at negative infinity, it starts at 0. But this is slightly changed because we have a y-intercept. This is definitely my y-intercept. Meaning no matter what I have, this function is going to be starting at y is equal to -1. Now, since this is a positive radical that we see up here, it's going to start at -1 and it's going to get bigger, meaning that it's going to start at -1 and it's going to gradually increase over time. What I probably should have done is show what a radical looks at the base, but I will change that in just a moment. Let me finish talking about domains. Alright, so when it comes to domains written in blue, everything depends on what can actually go into this radical. You cannot get a negative number in a radical and get a real number as your answer. Meaning, I cannot have anything less than 0 under this radical and it still exists. Meaning, whenever 2x plus 4 is less than 0, cannot exist. Can't exist. So if I solve for that, 2x cannot be less than -4, x cannot be less than -2. And I got that by dividing -4 by 2. So for my domain, I can't have anything less than a -2. And for my range, I can't have anything that's less than -1. Now let's actually see that in our problem. So I believe it was the square root 2x minus 4. Nope. It was 2x plus 4, wasn't it? Minus 1. So, if we look at this, this is our function, square root of 2x plus 4 minus 1. And all radicals have this approach. They start at some point out of nowhere, and then they increase gradually over time. Because you can always take the value of a square root as long as it's positive. And so, as I said, this is -1. If I can zoom in, -2, -1. You see that there's no value less than 2, as we said, less than -2, because I can't put a negative value in a square root. And there's no y value less than -1, because -1 is our intercept. It's where the equation starts. And I want to compare that to this, and this one in red, if you can see it, is our normal square root of x. It starts at 0, 0, can't have negative x's, can't have negative y's, and it increases over time. Because you can see, oh, what's the square root of 4? 2. What's the square root of 9? What's the square root of 9? 3. And so it's just doing square roots over time. And my cat is currently behind the TV. Don't know what she is doing back there. Give me just a moment. Alright, for this check for understanding, I want us to be able to identify what is the domain and the range of our question here. Alright, so I decided to go get Minerva because she wanted to be on camera. Cute little patootie right here. But when it comes to finding the domain and range of this problem, I need to fully establish, okay, what can I put into this and it still be positive? Well, if I have x minus 3 cannot be less than 0, and you know, the little alligator mouth with a line through it means cannot be less, well, x cannot be less than 3. So the domain really is anything 3 or greater. Remember, if it's less than 3, can't be in the domain, because we just established it can't be less than 3 up here, where I would get a negative number in my radical, and I don't like that. So the range is a little bit tricky. We don't see any sort of intercept at the end, so we can assume that, okay, it's a normal radical. It can be 0 or anything greater than 0. But we do have this negative out in front, which turns my entire radical negative. It has the same starting point. It has the same starting point because most radicals, if you don't have a y-intercept, are going to start at 0. But instead of going to positive infinity, this one is going to go to a negative infinity. Now let's see the evidence of this. Or let's see that we're right, really. Let's get these out of the way. And I believe that this was the square root, or the negative square root, of x minus 3. Oh, what's this? Starts at a positive 3 on the x values, and it is going down to negative infinity. So that one's right. And didn't we say, oh, 3 and 0? So now that we have really the idea of domains and ranges for radicals underneath our behind us, let's really talk about graphing them and how we can make it pretty easy in graphing them. Though, considering we did talk about domain and ranges and graph them, this section is going to go by very quick. So suppose we want to graph this. The first thing you should always do is establish, okay, what's going to be your domain, what's going to be your range. And domain for this is anything that I cannot put into the x and it still work. Well, the only way to turn 4x less than 0 is to, have an x has to be less than 0. Domain is where 4x cannot be less than 0. Well, 0 divided by 4 is still 0, so x simply can't be less than 0. So the domain is really 0, or I should put a closed bracket there. The difference between open and closed brackets is an open bracket means it's an open bound, because infinity is just a concept, it's not really a number. That's just saying it can keep going infinitely. Closed bracket means it has to start at 0 and then get bigger. You can't have anything less than 0. The range, well, it looks like we actually have a y-intercept and it's positive. So the range is going to be similar. It's going to be 5 and infinity. So if I were to graph something like this, and I would draw a much better axis, but I would assume, okay, if that's 5, and this is my value over here. One thing that is definitely true about graphing is if you can understand, if I can understand what your graph looks like, then that's fine. Your graph doesn't have to be super duper accurate. But yeah. And that's what it'll look like. Let's see if we're right. Looks like we're right. Alright, ladies and gentlemen, once again, this one's going to be pretty short because once you understand domains and ranges, graphing radical functions and radical equations, super easy. Super easy. What are the intercepts? Forgot I had this question. Well, there is no x-intercept because it does not touch the x-axis. There is no x-intercept, but there's definitely a y-intercept because it touches the y-axis at 5. Alright, let's move on. Graph the following radical equation, ladies and gentlemen. This is your check for understanding. And I'm just going to put this here. That's a much better axis. What are the domain and range? What are the intercepts? So, domain and range. Domain is that it can be anything 2 or greater on the x-axis. Remember, domain is x-axis. Range can be anything -2 or greater. Now, once again, the big part about this is that the domain is anything that you can put into this radical and still get a valid answer out. And that can apply to anything that's not radicals either. It's anything you can put into an equation and get a valid response out of it. The range is anything, okay, where's your graph going to be? Or where is your graph not? Like, we don't have any values that are going to be less than -2 here. And we can tell that it is a positive because there's not a negative sign out front. And if that's a -2, or if this is a -2, and that's a +2, well, it's going to start, going to change it to something not black. So we can actually look at it. Let's change to dark blue again. And there you go. That's what it's going to look like. Let's see that we are right. Oh, looks like we're right. -2, 2, -2. Alright, ladies and gentlemen, this is going to be it for today. Tomorrow we're just going to talk about a 5-minute subject about order of operations, because I think understanding the order of operations can definitely help us understand how to do mathematics better and what order we would do those mathematics in. But ladies and gentlemen, as always, until this all blows over, stay inside, stay safe, and hope you have yourselves a great Thursday.